All right, what's up? Today I'm with my colleagues. So we want to just follow this Google lab on building a multi-agent system step by step. So as I walk you guys through it, I will explain some concept along the way. So I'm Perete Harrison, a DevOps Software AI Engineer here with Atop Web Technologies. All right, Koye, you can introduce yourself so that we can go.
Hello, everyone. Koye, a front-end development engineer here at Atop Web Technologies. Nice to meet you guys.
All right, nice.
Yeah.
So first, we want to give credit to Amit Maharaj. Probably is an Indian, right, Koye?
Yeah, probably.
Yeah, I think so. Or Pakistan, thereabout. So this is a code lab from Google, which is building a multi-agent system. So the gist here is that you can take the same concept to build whatever multi-agent system solution you have. So it's still the same thing. So you can follow this lab, extract the knowledge, then use it to build something else for you, for your company or for your services or whatever that you're doing. So it's a transferable knowledge. So let's see. This is the first time opening this, and I don't know what we're going to face along the way, but we will do it, Koye. What do you think, Koye?
Yeah, agree.
Yeah. So we're gonna do it. So all right, let's see. Again, I have a vast knowledge when it comes to building multi-agent systems. So just in case that you're trying to follow any of their code lab and you get stuck along the way, you can use. We'll put a link behind this under this video. You can use atopgrow.com to book a free mentorship with myself. So we're about to launch this platform. So we are onboarding some of our engineer. So even Koye, I think you're trying to make some fixes, right?
Yeah, currently I'm making some fixes to the UI, to the client side. Yeah.
All right. So you can go ahead and you can book a one-on-one free AI section with me here. And I'll be able to guide is free for 30 minutes. Likewise, if you have Nest.js, React, you want someone to mentor you, Koye is there. He will mentor you as well. So you can book a free 30 minutes with him. All right. So with that being said, let's continue. All right. So building a multi-agent system. Let's see. So again, I'll just retreat, then walk through the example, and you can follow the same step by step to achieve it as well. And as time progresses, I might leave a bonus. So if you're ready and I'm ready, let's get this up and running. So are you ready, Koye?
Yeah, I'm ready.
All right, let's go. So what's going on here? Let's see what we have. Okay, I just want to zoom a little bit. Okay, I think this is okay. No? Yeah, this is fine. So this is more good. So let's see what the introduction is all about. So it's saying that in this lab, you will go beyond simple chatbot and build a distributed multi-agent system. While a single LLM can answer questions, real-world complexity often require specialized rules. You don't ask your backend engineer to design the UI, and you don't ask your designer to optimize database queries. Similarly, we can create a specialized AI agent that focus on one task and coordinate with each other to solve complex problems. That's true. That's true. So you will build a course creation system consisting of a research agent. Of course, if you're a researcher, if you want to research on a specific course, you definitely would use a search engine like Google, ask.com, bing.com. So you would definitely want to use a search engine to do research. So judge agent, criticizing, critique. Okay, just to criticize the research for quality and completeness. Yes, of course, if you do a research, you might want to refine it again. You might want to take it to a different body to look at it, to give you a feedback. So that's what this judge agent is doing. So content builder agent, turning the research into a structured course. And orchestrator agent, managing the workflow and communication between these specialists. Yeah, just like Kubernetes. So prerequisites, you need basic Python. Again, you don't have to know Python. Yeah, there's the same knowledge. So if you know how to use JavaScript, I think ADK, which is what ADK has, you see, they have Python, they have JS as well. They have Go, Java, and Kotlin. So it's the same thing. There's no different. So be it Python or JS or Go, you can easily transfer the same knowledge, the same code. You can easily convert it to that of any specific programming language. And familiarity with Google Console, okay, which doesn't require, but is good for you. It's good to know. So what should we do? Define a tool using an agent researcher that can search the web. Implement structured output with identity for the judge. And yes, of course, we need a structured output as well, because if you, I know I'm taking time here, but if you use Gemini, for example, share, or you're not open. Okay. So if you ask, what is for example, you say it will spit out the answer in a somewhat not structure. It's structure. For example, you see, we have this. We have how to identify sword. We have why do we use sword, and you see these are kind of a structural ways the output comes in. So if you're writing such complex multi-agent system, you definitely need a structured way from the LLM. But sometimes LLM they have like let me say the way they spit out information is not necessarily structured, yes, it's not necessarily structured, but if you want it to be structured, so you need a well-typed structure framework for that. So in this case, we're using this Dante for the judge. So connect to remote agent using the agent-to-agent protocol. Construct a loop agent to create feedback loop between the researcher and the judge. So run the distributed system locally using ADK. Deploy the multi-agent system to run Google Cloud. All right, so here's the architecture. Instead of me to instead of me reading all the words, to make things fast, because we have less time. So I will just talk about just the most important one. So this is the architecture of the architecture and orchestration principle. So the system design, this is our front end. The front end communicate with the orchestrator. So the orchestrator and the researcher, likewise we have a writer as well, and the judge is also here. So this is the system design architecture. And as you can see, the explanation here is very, very intuitive. So it said standard agent like the researcher do work. Orchestrator agent like standard agent like the researcher do work. Okay. Orchestrator agent like loop agent, sequential agent, manage other agents. So they don't have their own tools. Their tool is delegation. So we have the loop agent. This act like a while loop in code. So it runs a sequence of agent repeatedly until a condition is met. And then we have the sequential agent. This had like a standard script execution. It run agent one after another. So we use this for the high level principle. So first, run the research loop, then run the content builder to write the course. By combining this, we create a robust system that can self-correct before generating the final output. Yeah. So we're done with the first introduction, so let's move on. So yeah, has to do with the setup. So what we have is okay, if you want to learn at no cost, but it's fine. Switch account to claim your no cost credit. Activate a Google Cloud credit at no cost. We already have a Google Cloud, so no problem. It's very simple. Just click on the README, you see there. So since we can do this within the terminal, I can fire up my Google Cloud for this. We can do this offline, so I can go to Google Cloud. Okay, so we're done with that. So the first one is to clone the starter repository into your home directory. Should we just use our terminal, or should we use the cloud share or locally? It's still the same, but just that the step is different. Due to time, we should just stick to this, right? Stick with this.
Yeah, yeah.
All right.
So that, yeah.
Okay. So clone the starter repository into your home directory. Yeah, very simple. So we do git clone. The depth is 1, then we filtered by Yeah, because there's a lot of demo here. So that's why we're doing all these. If you go to this, there's a lot of code labs there. See, so we have different code labs here. These are different code labs. So in order to filter through it so that we can successfully get this agent built with AI, production ready AI, and whatever. Let me see what we are moving the temporary agent build to the folder that we'll create. Then we'll remove the temp. So there's a lot going on here, but very simple that's going on here. So if you want, we can even break this down. We can, just in case you're confused that what is going on, you can break it down. So break this to just in case you're wondering, there's nothing here. So it just is the individual command that is stitched together. Yeah. So I don't, the explanation is too much. So it's succinct. All right. So yeah, we git clone with no history into the folder, this temporary folder. Then we change directory to it. Download and review only the specifics of directory requested. Then move back to the parent directory, then we delete it. So that is a very simple command, but this command are stitched together. So just in case you're wondering why is it like that. So we can do it. Just let me see what I have here. ls-l here. So can we just all right, fine. Nice. So this is what we have. So paste these. All right. So now what do we have? So now we have this root dash lab dash one startup. So just need to follow this instruction. And so we need to change directory to it. Okay. And yeah, let's list what we have here. So these are our Python codes. We have the agents, we have the app, and some other stuff that is here. As time progresses, I might take time to explain some of it. So we need to enable some APIs like cloud build, for example, AI platform, compute, and the registry, because we'll be building this using Docker. So if you're wondering what is this Google Cloud services that we enable, these are individual services. So to enable several services, you use this Google Cloud CLI. So it's already installed in this within your Google console. It's already installed. So if you wonder, you can just type this G Cloud. So it will spit out list of commands for you. So So available groups for Google Cloud. So they really have a lot here, but we are not here for Linux foundational class. So I'll just proceed. So again, what is happening here is that we're enabling different services like artifact registry. So these are separate services from Google. Yeah, this is the documentation package manager for your build artifact. So we have Cloud Build, of course. Cloud Build is similar to that of AWS Code Build. So these are more of DevOps tools. AI platform and compute. This is just an instance, a virtual machine. So just need to enable everything once. You can as well run the same command separately. So, but we're running everything once. All right, so open this folder in your editor. Then install dependency. So we use UV for fast dependency management for Python. So install the project dependency. So ensure you have UV installed. It doesn't have it. So we just need to check if we have UV installed in this terminal. Yes, we have it here. So the available command is that you can create a new project, you can add dependency, you can remove dependency. So it's what it's saying here that we need to install the project dependency. And so if this is not installed, you can just you can install it. So okay, so let's install this with UV sync. Fine. There are bunches of services here, that packages that is installed. Not installed, though. We just like UV sync is to update the project environment. Set up environmental variables. So you can find your project ID in your Cloud Console dashboard by running this, of course. Then we create .env file to store this information. So if you run this command, this will spit out your project ID. But of course, you can easily just get it from here. So we have several projects here. So this is my project ID here. I'm using this keylog. So if you run that command, it will get it out. It will get it for you, which is this. So, but because we are here, we can put the. If you want us to create the .env file and export that a project ID, the Google Cloud location, which is global, and the Gen AI we're using Vertex here. Yeah, so again, this is just the simple command. So we have .env file, so we can .env. Let's see what we have here. Okay. If you like, you can run this command, this cat command, and it will update it. Or if you like, you can just copy the same information here and paste it. Just We can as well just rename this to .env. So it's still the same, but for the sake of this tutorial, so that it doesn't get confused, we can just run the same command here. So now we have a .env file, which is this, and if we cut it out, we have this exported environmental variable that we have here. So we just need to load it to source. So it's now available. So now, step 3, the researcher agent. So what's up, Koye? How's it going from this stuff?
Yeah, I'm enjoying it so far.
All right. So we still have a, let's see what we are. We still have, how many steps we have remaining? Still have 7 steps, right? There.
Okay, yeah.
All right. I'm trying to lower my deck so that I can see them. Okay, so the researcher agent. The researcher agent. So we have the researcher, and also we're giving the researcher a tool. In this case, we're giving it a web tool to search in an internet. Of course, for example, Koye, let's say if you want to research about, or probably you want to know about the latest release. Of course, since you're a React expert, thereabout. So normally, what will you do? You will open a Google, right? Then, or probably you navigate to React.
Okay, yeah, the websites, their blog. Yeah.
Yes, exactly. So you go to their website and you do your research, right?
Yeah.
Yeah. So it's still the same thing. So the researcher agent, we're giving the researcher agent a web search capability so that I can use search engine to do his research. So that's what we have here. So let's see what's, again, we don't need to waste time to explain it. Otherwise, we'll just spend unnecessary time in this thing, which is something that we can do in less than 30 minutes or even 20. But so, yeah, the researcher is a specialist. So its only job is to find information. To do this, it needs access to a tool, Google search tool as well. Not only that, apart from giving it a Google search tool, we can give it several tools. So if you go directly to ADK website and let's see, let's search for tools. Yeah, we have a list of tools. Let's see. Build an agent. List to stream agent. Simple agent. Where are you? Looking for the list of senior reference. No. Start building. Yes, so we have agent. Equip the agent with a tool. So where is the list of tools? You can as well create a custom tools for sure. We don't have to waste time here. So is there in the documentation? You know, they keep updating it every now and then. So let's see, build Python. We have for you to install. Let's go. Video agent, multi-tool, two agent team, discovering, set up ADK. So the gist is that you can give your agent different tools. So there's a tool, for example, a coding tool. So that will be responsible to write any code. Browsing tool as well is also there. Search tools to use the internet. So you can give agents different tools. And the good news is that you can as well create a custom tool if you want to create a tool. Let me search for search tools. Yeah, but yeah, so this is for the Gemini API Google search tool for ADK. But where is the list of tools? Yes, we also have coding tools also there. Or code execution. Wait, we need to check this thing out. We need to find this. You know, the documentations change every now and then. So we have getting started. These are all other languages, any other language that we can use. Agent, graph workflow, multi-agent workflow, model for agents. Yeah, this in the integration is here. It changed, it changed, and also it has been longer. Even use the ADK, so it changed. So this is it. It's here now. It's under the integration. So these are tools and for the agent. So for example, these are coding tools that you can empower your agent with. Wow, this is really increasing. Now they have Google Kubernetes NG code executor. Even GitLab. This wasn't here before. So there were code execution tool with agent runtime. Code execution as well. So I think this is every day by day, like new tools are coming. So like Google, for example, we have, wow, you see, now they have integrated a lot of their services, different services to it. Computer use to is what I wanted to say, like an agent can definitely open your browser and use your computer for it. And yeah, there are several tools here, so we don't have to waste time. Even MCP is also there, like observability as well is also here for. But so Datadog, they are finding their way here, which is pretty good. Grafana as well is here. We say different connector as well. So it's still the same thing. If you are not using agent development kit, if you want to build a multi-agent, you can as well use a Crew AI. Yes, Crew AI. Yeah. Can as well use. They have tools as well. Can use Crew AI. And I think you can as well import Crew AI to. You can use Crew AI as well within agent development kit. You can use LangChain as well. So if we look for their tools, they have different tools here as well. Let's see their tool repository. So each of any of these agentic framework, they have tools available. Yes, you see they have tools here. You have coding tools, like different type of tools. You'll find it. So the more you dig into it, so the more you find it. Not only this as well. If it is LangChain as well, you can as well use LangChain to build the same thing. Even Azure as well, they have their own framework for you to use. So they have several frameworks now are being emerged. So, but for me, do you want to know my go-to, Koye?
Okay.
Yeah, it's this agentic ADK from Google. It's my go-to. Yeah, I've used several ones. I've used LangChain, I've used Koye, I've used ADK, and even the one from I think I didn't not for production, use it personally from Microsoft. It's called Azure. Yes, I think what is that framework? Forgot the name. Anyway, let's leave that. So let's just focus on this. So I don't waste more time. All right, so we're back. How many minutes we have been here now? But we don't have to spend more than an hour for this.
I wasn't counting. I think it should be over 30 now.
All right, let's go. So next we have why. Okay, now it's justifying why separate the researcher agent. So why not just have one agent do everything? So small focus agents are easier to evaluate the bug. If the research is bad, you iterate on the researcher prompt. If the course formatting is bad, you iterate on the content builder. In a monolithic do it all prompt, fixing one thing often breaks another. That is true. So if you're working on CloudShare, run the following command to open the CloudShare editor. So CloudShare workspace, then dot to open the CloudShare editor. And you can use this, or you can just use this. Any which one work. All right, so we have this as well. All right, fine. So we can proceed. They want us to open the agent and the researcher agent. So there we'll find different agents. If you go to agent here. So if we have the researcher agent, the orchestrator, the judge, and the content builder. But now we want to focus on the researcher agent here. And you see a skeleton with a to-do, then just replace it. Define the researcher agent. Again, don't be confused. An agent is just a, sometimes I use the word like a class, a function. But in this case, this agent here is a class that has different, you initialize it, and an instance of it with the name, the model, the description, and instruction. So import the agent and pass the name, the model. Of course, we're using this, it's already defined here, this variable. So the description and the instructions. And last but not the least, we just need to use the root agent, because the researcher is, of course, the root agent. So fine. So when using Gemini 3, the Google search tool is automatically available. So if you are using a different model, you would need to pass in the tools, okay, as an additional parameter to the agent constructor. ADK handles the complexity of distributing this tool to LLM. So by default, this model include a tool, so we don't need to include, don't need to pass to this instance that we created. I wanted to expose the structure of it, but it's fine. All right, so we have that. Then next, we're progressing the judge agent. So what it does is that this is the researcher. So linear algebra is a branch of mathematics, just like how you would research using a Google search. And of course, you submit it to that of your lecturer or your teacher or your instructor. So now we want to define a judge agent. Again, judge agent is very simple, not complicated. So we open it and define the judge feedback, then define the agent as well. Then of course, let me just copy this in. So the way it works is that when the researcher completes his job, so then we need a judge to review the work. So the judge accepts the research and return a structured pass or fail assessment. So the name, the model, description, then so you are a street editor. Evaluate the research finding against the user original request. If you find you are missing key info, return status as failed. If you are comprehensive, return status as and pass. Then pass the judge feedback. So we don't want it to delegate. So disallow delegation because it should only output the schema. So disallow transfer to parent true, then disallow transfer to pair true as well. Then we return the judge. Then we have the judge here, the root agent. Again, we're using this pydantic for the schema to define the schema. You remember you use Zord, right? A lot in TypeScript.
Yes.
Yes, Zord. So it's the same thing. What is going on here? All right. So that is it for the judge. So now we are safe to move on to the next. So it's safe for us to move to the next. So testing in isolation. So before connecting them, we can verify that each agent works. So the ADK allows you to run the agent individually. So the interactive runtime. So ADK run spin up a lightweight environment where you are the user. This allows you to test the agent instruction and tool usage in isolation. If the agent fails, for example, can't use Google search, it will definitely fail in the orchestration. True. So run the researcher interactively. Note we point to the specific agent directory. Yes. UV run. Remember that when we to test each of the agents. If you see from this UV, we have run command here. So we're using this run a command or a script. So in this case, we want to run each of the agents. So we're running the researcher agent. So yes, allow. So we'll do this. Yeah, sure. So we can in the chat prompt, we can just like find the population of Tokyo in there. So we can just find the population. We don't have to do Tokyo. Do a let's do some let's do somewhere in Africa. Let's do Abuja. A lot of Tokyo are there. All right. So this figure generally refers to the population of Abuja. It is important to know that population estimate can vary. Okay. Contextual data. Yeah. So it's spit out and which is working. Because you use Google search and return the answer. Note if you can see an error indicating a project location. So now you see let me see this researcher. Yeah, so we just ask, you are an expert researcher, your goal is to find comprehensive and accurate information. So that's what happens. So you use the Google tool, the Google search tool to figure out this out. So let's proceed. These are just like for some caveats, some errors, of course. As well, we can run the judge as well to really evaluate this. So we can close this. And we can which is this. So we can just pass in this, but again, remember we need to change it to that of Abuja. Yeah. So this is the user status is failed. Feedback, the findings are extremely minimal and lack essential information. So a comprehensive overview should include that Abuja is a capital city of Nigeria. It statues as a planned city built in 1980. Yeah, you see the essence of the judge, right? How the
Yes.
judge works. Yeah. So which is very good. So again, remember that this same concept, what we're doing here now, Koye, is that we can use it to build anything that we can imagine. For example, I'll give you an example. If you want to build a multi-agent system, let's say in an hospital settings. So one agent will ask the patient question. So why are you here or thereabout, or what do you want? So that agent will be responsible to extract information from that patient, then pass it to a judge to evaluate it. If the judge evaluated that we don't have more context, it will return it back to the agent. Oh, what's up? What the patient is asking is that we don't have more context. So the researcher will go ahead to, or the front agent will communicate with the patient until it gathered more context. Then once the judge is satisfied, they'll move it to a different agent. So with this in mind, imagine the type of things that you can build. You can as well apply it to your front end, to your back end as well. One agent will be there for writing a React component. Another agent is there to evaluate that React component. So the sky is your limit here. So you can do whatever you imagine with this. So let's proceed. So it should return status free because the findings are too brave, which is true. So it failed status. Failed. So you see, in JavaScript, what we call this object, right?
Oh, yes.
Yes, we call this object in JavaScript. It's still the same. L programming, they are almost the same thing, solving a short problem. In Python, they have different type dictionary, tuples as well. So different data type is there. So it's just the same, but different words. So let's go to the next. So the content builder agent. So linear algebra is a thorough branch of mathematics. Then once we have our research, then we pass it to the writer. Then the writer will write it into a formatted layer. So we have this. Again, you can as well use this for your own personal blog. If you're building your personal blog as well. So that's what this content agent is doing. Very simple. So did you see how booming this agent is all about, is everywhere in the internet? Sometimes if you're not careful, you'll be scared, right?
Yes, everywhere. Everybody's always talking about agents, this agent, that. So
Yes,
yeah, it's very common.
Yeah, but you see what is an agent, right? Very simple.
Yeah.
Very simple. So now let's just define the builder, the content builder or content writer agent. Content builder. All right, so I can copy this and swiftly go to this and add it here. Yeah, the name, the model, the description, transform research finding into a structure course. So then the instruction. So we give the rules here. Start with the main title. Use these, use bullet points, and maintain a professional but engaging. Again, you can fine tune here. Again, the the ball is on your court here. You can do whatever you want to do from here. So you're free to do whatever you want to do from here. All right. So it talks about the key context propagation. Okay, it's just talking about, you might wonder, how does the content builder knows what the researcher found? So in ADK, agent in a pipeline share the section state. So later in the orchestrator, we will configure the researcher and judge to save their output to this shared state. So the content builder prompt effectively has access to the history. Yes, I think this is a very good caveat. Now, the orchestrator. If you're wondering, these are just normal terms. If you check orchestrator in the music, you see you have a guy, like you see somebody in the music conducting. You remember those choir stuff, right? Like this. You see?
Yeah.
It's just an orchestrator. So that is where the term is derived from. Like Kubernetes, for example, is what Kubernetes is doing when managing a variety of different containers. So nothing special. Yeah, this is it. So it's the orchestrator. So this is the agent we want to build. So orchestrator has a state, of course. Then we have to the researcher, judge, and the writer as well. So let's see, the orchestrator is the manager of our multi-agent team. Unlike the specialist, research, judge, content builder who perform specific tasks. The orchestrator's job is to coordinate the workflow and ensure information flows correctly between them. So we have the architectural agent to agent. Agent to agent can communicate, the researcher to the judge, then researcher to the writer, then writer to the judge as well. Because the judge needs to check the write-up as well. So in this lab, we are building a distributed system. Instead of running all agents in a single Python process, we deploy them as an independent microservices. Again, I'm in favor of these, but sometimes this might cause some unnecessary complexity to this, especially if you're just starting out. Especially if you're just starting. This might really cause some unnecessary complexity. So why is good? Why using the term distributed system and that of individual microservices, which is good, but remember it comes with its own disadvantage as well. So, but if you're starting out, start small. You can start with monolithic. It doesn't mean sometimes monolithic can solve your problem. So as time progresses, you can move on to that of distributed system or using microservice way as well to solve your solution. It's always best for you to start small, even when it comes to prompt. So I worked in a situation whereby you will see a very large prompt confusing the AI as well. So start small. A simple prompt might really solve a lot. All right, let's go. So yeah, what is going on here is each of those agents who will deploy it independently. So, and of course, they will have to communicate with each other. So that's why we have this A to A, agent to agent communicating together. It's like the same thing, Koye, what Nest.js is trying to solve with React. You know, if you're writing React, right, you have to write your own backend. Yeah, you need to bring in your router, right? Your
yes.
They have state management. Again, it's still the same thing. Sometimes you can shed some light about this. What do you prefer? If you're building a simple application, do you prefer to use a third-party state management within React, or will you just use what React has to offer?
Okay, for smaller projects, I just use what React has to offer.
Yeah.
Because in that case, even if you want to keep the states between pages, context is like if your project is smaller, then you can just React context without issue. It's when it's getting bigger that I think it will not be an issue.
Yeah, I have this dilemma, especially with before. What is this? That lightweight state management tool that you're using with React and Nest?
Zustand.
Zustand, yeah. Before Zustand, we know then is for larger project is Redux, right?
Yeah.
Yeah, Redux. You know that Redux comes with its own complexity. I hope you know. I hope you understand.
Yeah, that's why they want to create toolkit again to even break it down again.
Yeah. So sometimes it is better for you to use the native built-in state management for medium project, because you don't not necessarily need all this external super powerful state management, especially Redux. But Zustand is very light.
Yeah,
it's very light, which is good. All right. So for me, since we just have how many agents? We have 1, 2, 3 agents. Oh, almost. Yeah, how many agents do we have here? Let's see. I might not be in favor of this. I might debate this, but of course, it's one of the best practices to do. So we'll deploy them as an independent microservices. So again, we need to, that is where A2A comes into play. So this allows each agent to scale independently, fail without crashing the entire system, which is true. So to make this possible, we use agent-to-agent protocol. So the A2A protocol. So of course, let's just deep dive. In a production system, agents run on different servers or even a different cloud. So the A2A protocol creates standard way for them to discover and talk to each other over HTTP. Remote A2A agent is the ADK client for this protocol. So we need to open this orchestrator agent, locate the to-do define connection to remote agent. They'll need to add the following code to define the connection. All this information, this connection here. So we'll look for the orchestrator, the agent. There's a lot going on here, but again, it's very simple. And everything is explained here as well. So we have the callbacks function. So we need to define our remote agent, the escalation checker, and the orchestrator. So I think we have everything here. This will connect to the researcher agent. Take note of the port as well. So just in case you deploy to a different cloud provider, we definitely need to update all this. So just copy this. Define connection to the remote agent. Let's see. connection to the judge, content builder, connection to researcher. Okay, there's a lot we need to do here. So let's leave these special ops. Different connection to the remote agents. Connection to the researcher. Yeah, I can just copy this. Researcher, judge, builder. Okay. So we have this. All right. Okay, so we have the researcher URL here. So we grab this researcher agent card URL from the environmental variable is set. We also have these. We have the remote A2A agent. We have the connect to the judge. The same thing apply, and connect to the content and builder. So let's proceed. So now the escalation checker. So a loop needs a way to stop. So if the judge say pass, we want to exit the loop immediately and move to the content builder. Yeah. Once researcher research, pass it to the judge, and judge set judge return positive, then of course we need to pass that research to the builder. Custom logic with base agents. Not all agents use LLM. Sometimes you need a simple Python logic, like base agent, lets you define an agent that just run code. In this case, we check the session state and use event hashes, which escalate is set to true to signal the loop agents. Yeah, which is true. Sometimes not all agents require LLM. So a basic Python code can pretend to be an agent. So stay in this, we find the escalation checker to replace with that. So again, this is just a class and bunches of methods that we have here. A class with just one method here, which is run async. We can copy this. Yeah, just exactly what is wrote here. That's what this code is doing. So this agent check the status of the judge feedback. If it is true, if it pass, it should escalate the break, which is to break the loop. So of course, we don't have all day to start explaining all this code here, but pretty simple. If you don't understand, just copy it and paste it to any LLM to explain it for you. To explain it. So agent communicates not just with test, but with event. By hitting an event with escalate through, this agent sends a signal up to its parent, which is the loop the loop agent is programmed to catch the signal and terminate the loop. So we're almost there. So the research loop. This is the loop agent. Then we have the researcher to the judge. So we need a feedback from research to judge, fail back to research. So of course we need those loop. So once you research a topic, you send it to the judge, and the judge disapprove it. We need to send it back again to the researcher. The researcher adjusts its research, send it back to the judge, and come back with pass. So we need that agent, that loop. So within the orchestrator agent, again, add the research loop. Place this after the escalation checker class and escalation checker instance. So we have the research, which is the loop agent. So we need to place this after the escalation checker class. So we have the escalation checker class. And after this escalation checker, this is here. So the way it works is the loop agent circle through its sub-agents. So researcher and judge. Find data and evaluate. Then escalation checker decide whether the yield event escalate true. If true happens, the loop breaks. Otherwise, it restarts at the researcher up to the maximum iteration if you set it. So the loop agent, again, name is research loop. Iteratively research and judge until quality standard are met. So the sub-agent will pass the researcher, the judge, and the escalation checker. The researcher, the judge, and the escalation checker will pass this here. So maximum iteration, we can put this to 5. So 3 is okay. So we can use 5. All right, so next is the final pipeline. So the final pipeline, so we're almost done. So we have the sequential agent. So again, we can use sequential agent. You can we also have like parallel agent as well if you want to. I think we'll talk more about that. So if you, within it, you go to workflow. Yeah, within a workflow pattern. So we have sequential pipeline is there, parallel, fan out and gather. Of course, you mind the loop as well. So in this case, we're using the sequential agent. So you see we have George, pass it to the writer, then writer to orchestrator. So finally, stitch it all together. So we have the still within the orchestrator, define the root agent at the bottom of the file. Ensure this replace any existing root agent person equal to null. Yeah, I think we've done this. All right, so we have the sequential agent. Again, this is coming from ADK. The name, the description, and the subagent, research and content builder. So the key concept, notice that research loop is itself an agent. We treat it just like any other subagent in the sequential agent. This composability allows you to build complex logic by nesting simple patterns, loops inside sequence inside routers, etc. And last but not the least, not last, so we still have some few things to do, to test and to deploy to Cloud Run. So run locally. So before we run everything, let's look at how the ADK simulate the distributed environment. How local development works. So in a microservice architecture, every agent runs as its own server, for sure. When you deploy, you will have 4 different Cloud Run services, okay? Yeah. Simulating this locally can be painful if you have to open 4 terminal tabs and run 4 commands. So this script starts UVI and con. So processes for the researcher, which is the Paul George, and content builder. So it sets environment variable like researcher agent card URL and passes them to the orchestrator. Okay. This is exactly how we'll configure it in the cloud later. All right. So since we have 4 agents, and since we're using a microservice architecture and that of distributed and system. So each of all these agents, the content builder, George, orchestrator, and researcher, we need to deploy them separately. You get it, right? Just like React component. Just imagine that you are deploying each React component. How painful is that, Koye?
Yeah, it's very hard.
Yeah.
Very hard.
Yeah. So still the same concept here. Now, linear algebra, the researcher is gathering information, researching, fact-checking, then writing. So run the orchestration script. So there's a script here, run local.sh. So we have a script here. I can open it from here. Run local.this. Yeah, of course, it's a very simple script. So the entry, so there's a bash and key any existing processes. Set the common environmental variable for local development. Start the researcher agent on port. UV run, okay. Then starting George with all the different, very simple, not as difficult. It's a very simple script. Yeah, so let's run the orchestration script. So Then we need to run it now. Okay. So we have 4 separate processes running now. So, which is all those agents, those 4 agents. So if you're using a cloud share, click on the web browser button, preview on this port. So change port to this. Okay, if running locally in your browser, create a course about history of coffee. Observe the orchestrator will call the researcher. The output goes to the judge. If the judge fails it, the loop continues. So if there's any error, we can as well testing the agent in a isolated way as well. So I don't think we'll face any error. All right, so just need to open the browser. Need to change the port to this. Yeah. So turn any topic into a complete course. So just enter a subject, and our team of agents will research, fact check, and write a comprehensive course for you in a second. So the example given here is to create a course about the history of life. So let's create a course about the history of computer. We're having an error here. Could not resolve project using application default credential. Okay. Let's see what is the problem here. There is some interesting issues here. Attribute error. Base API client object has no attribute. Okay. That's not fun. Did we do something wrong? Let's see some of the errors that is saying there. Internal server error, auth error. If you're seeing auth error, I'm sure you have run. Did we set this correctly? Comment. Yes, we have that set correctly. We haven't gotten all the to be reading all through this. Let me try to. Is there any way we can pass this to an AI? No, it's fine. When is the last time you read error? Koye? I don't have that time any longer.
I just copy it.
Yeah, we don't have that time again. What a life. What a time to be alive. We should incorporate Gemini with, okay, yeah, I think we have here, right? What is this? Okay, yes, fine. Base API client object has no attribute. This has to do with package related issue. All right. Yes, we did this. Hmm. Print off the directory. Okay. Researchers run on 8001 George 2 Builder in Orchestrator. So change the list. Hmm. Okay, let's use this agent here to fix it. This Gemini assist here. This is too much. This is too much. It's saying that base API client object has no attribute. That's the problem. I see why some folks will take this cloud um, code lab and run away. Are you? What are you doing here? Let's see. Are you trying to write something, add something to it? Hmm. Okay, just a minor thing that change. Let's see. Additional troubleshooting step, application default credential. If you still see could not resolve, make sure you have authenticated your local by running this. Yeah, I think it was, we have that as a troubleshooting, right?
Yeah.
Mm. Yeah, but this is just, But it will work now for sure. And run this command, do the preview. And there's the computer. Yeah. For sure it's working. Same error. We didn't get anything internal server error, terminal error. Why then are we still having this problem? 1 second. See what we have here. Let's just repeat this stuff. Yeah, more errors. This API client has no attributes. Could not resolve project using this evaluation check. Yeah. We set it. You must run the initialization script first to create a selected project. First, permission denied. So this is taking longer than I expected. Yeah. Of course, ensure your Google Cloud project is set to search. Let's run the script again one more time. Is a key is come out. No Google Cloud project ID set. That's false. But we're having permission denied. Let's run this first. And this will work now. Did you touch anything, Mr. This Gemini? Revert your changes. Let's do computer. All right, finger cross. Let's see. And cross. Let's see what we do. Yeah. Good news, Koye.
Okay, sorry. Okay.
Yeah. You see?
Yeah.
History about computer. So now we have course. From abacus to AI and history of computer. Yeah. So we have, since we debug the error, now next we can deploy to cloud run, understand the deployment configuration, each of all these, and capture the URL. Then we deploy the orchestrator separately. Then we deploy the front end. Then we can test it, which is very simple. Then you need to deploy it. It's very simple. Just copy paste. That's all. Do you have any need? No need, right?
I don't think so.
Pardon?
I don't think so.
Yeah, there's
No
no
need.
need. Yeah, it's very straightforward. So that is it about building a multi-agent system. All right. Thanks for watching. And if there's any solution you want us to help you with, you can reach us. All right, bye.